Okay, today we will go to interval estimates. Since it is incomplete data, so we need to estimate probability of survive or probability of death, the QX or the PX, first for the particular interval. So PX, the survival to age X plus 1. So this is considered as 1. Given that alive at age X. So if we draw the timeline here, so we only estimate the probability of survive for one interval. Since we want to estimate the SX, so we have to estimate probability of survive first. So it is incomplete data again. So we cannot, it is easier for us to estimate for each interval to get the overview of the whole data. As you know, the PX for the estimate, we have PX with the hat and the QX as well. This is the basic relationship. Okay, this is the general form. I already draw to you. So between only one interval, so we are looking for the PX, X to X plus 1. So if you write down in terms of words, it becomes like this: survival at age to HS plus 1 from X to X plus 1 given alive at age X. So meaning that here must be survive. Last time we cover on ordered pair. So ordered pair is YI and ZI, where YI is the entry age and ZI is the exit age. So we already covered last time in observation period. So the information that we have to know 3 basic information, where we have to know the date of observation period, the entry age and the exit age. Okay, now what's the difference between last time and now? Well, last time we consider the observation period. So now we just want to cover only one interval. So we just want to focus in one interval for the subject I, whether it contributes to the observation or not. So we have 3 cases, 3 situations here. Okay, we will look one by one. So the 3 situations, first one, when ZI, the exit age is less than X, or YI is greater than X plus 1. So if we draw the timeline, so we have, this is the interval estimate, X to X plus 1. So we are interested only for this interval, the interval estimate. ZI is before the exit age. So exit age, this is the entry age. So the exit age is before here, somewhere here. Before here. Let's say ZI is here, before X. Or YI is greater than X1. So the entry age is after X plus 1. So in this situation, we consider the subject I is not contribute into the interval estimate, because the entry age is after the interval estimate, or the exit age is before the interval estimate. So we conclude that it is not contribute in the interval estimate for this subject. Okay, we look into second case. So YI is less than X and ZI is greater than x plus 1. So we draw the timeline again. So we have the interval estimate here, x to x plus 1. So this is the interval estimate. So yi is less than x. So yi, somewhere here, let's say here, yi, and zi is greater than x plus 1. So zi become here greater than x plus 1. So we take 1 point here and we take 1 point here. So interval estimate is in between the entry h and the exit h. So we consider this as contribute. So this one is contribute to the interval. Okay, for the third case where yi is in between the interval and zi is also between the interval. So we draw the timeline. So this is the interval estimate, x to x plus 1, yi here, and zi also in between x and x plus 1. Remember, zi must be after yi because yi is entry h and this one is exit h. So entry h must be before the exit h. So the interval estimate is all here, and the entry and exit h is happen in between. So still we consider it as contribute in the interval estimate. The entry h and the exit h is in the interval estimate. So this one, even though it starts before the interval estimate and after the interval estimate, still they share the same period for the certain point. This one, for the first one, they do not share any point. So we consider it's not contribute. In example 1, for member A, remember, member A, the yi and the zi is equal to 34.75 and 38.75. And then for example 2, member B, yi and zi is equal to 48.5 and 53. And member C, in example 2, the yi and zi equal to 31.33 and 35.33. Let our interval estimate um 52 and 53. So the interval estimate is 52 and 53. So before this we use x and x plus 1. So x equal to 52, x plus 1 is 53. So for member A, if we draw the timeline, so interval estimate is 52 to 53. So yi is 34.75. Zi is 38.75. This is yi, this is zi. This is x, this is x plus 1. So yi and zi, the entry h and the exit h is outside of the interval estimate. So member A considered as not contribute. So we still use the interval as the same interval estimate. Say we try to find member B. We want to determine whether it contributes or not contribute. So still the same interval estimate. However, the yi is 48.5 and zi is 53. So zi also 53. C. So the entry age and the interval age is share the same point in the interval estimate at one point. So we say we consider member B as contribute in the interval estimate. So how about member C? So member C, yi is 31.33 and zi is 35.33. So before the interval estimate, so member C is not contribute in the interval estimate of 52 and 53. So member C also not contribute. Now let a person I enters x and x plus 1. This is the interval estimate. And at each x plus ri and x plus si. So we have new notation here. New notation ri and si. So the entry age is x plus ri and the exit age is x plus si. How to determine ri and si? The first one, the first case, we have two cases here. So if yi less than x, ri is equal to 0 or zi greater or equal to x plus 1, si is s1. So if we draw the timeline, first case, let's say the interval estimate is 50 to 51. The x and x plus 1 is 50 to 51. So yi is less than x before x. So yi, let's say 48.5, let's say. So zi is greater than x plus 1 for the first case. So let's say zi is somewhere here. Zi is 52.3, let's say 52.3. So how you want to determine the ri? So yi zi is 48.5 and 52.3, 52.3 for the interval of estimate 50 and 51. 50 and 51. So this is the interval estimate and this is yi and zi. How to determine the ri? So ri is the entry age x plus ri. X plus ri. So when yi is 48.5, x is 50. So 50, okay. So yi is before x. So yi is less than x. So it before x. So that we consider ri equal to 0. And si is greater than x plus 1. So we consider si is 1. Okay, so this is the first case. If yi before x and zi after x plus 1, ri and si is equal to 0 and 1. Okay, so the second case where the interval estimate, let's say we still take 50 and 51, and it happens that yi and zi in between. So Ri will be between 0 and 1, and Si also will be between 0 and 1 for the second case. Okay, let's say I give you example for the case 1. We refer example 2 for member B. So member B, the Yi and the Zi is 48.5 and 53. Okay, let's estimate interval (52) and 53. So let's say the interval estimate is 52 and 53. Determine Ri and Si for member B. Okay, if we draw the timeline, so the interval estimate is 52 and 53. The interval estimate is 52 and 53. So the x and x plus 1. So Yi is 48.5. So before the x. So this is Yi. And Zi is 53. So Zi also 53. So how determine the Ri? So Ri is before x. So Yi is before x. So when Yi is before x, we consider Ri is Yi if equal to x or before or less than x, we consider Ri is 0. And Zi if greater or equal to x plus 1, as in the case 1, Si become 1. So Ri and Si is 0 and 1. Case 2, let's say participant 1 Yi for Zi for participant 1 is equal to 52.5 and 60, for example. So the interval estimate, let's say, between 52 and 53. So if we draw the timeline, the interval estimate still 52 and 53. So this is x, this is x plus 1. So this is the interval estimate. And the Yi is 52.5. So after the x. And Zi is after x plus 1. So 60 here. 60 Zi. So Yi is in between the interval. So Ri become between 0 and 1 in case 2. So so Yi is x plus Ri. So Yi is 52.5, x is 52. So Ri is 0.5. So 0.5 is between 0 and 1. However, Zi is greater than x plus 1. When Zi is greater or equal to x plus 1, we consider Si is as 1. So therefore Ri Si is 0.5 and 1 for the participant 1, for example. For the case 2, the example for case 2, and this is example for case 1 for this for both situation. Okay, let's say participant 2 for case 2, given that yi and zi equal to, let's say, 49 and 52.78. So we still use the same interval estimate, where 52 and 53 is the interval estimate. So yi is 49, where before the x, 49 yi. So zi is 52.78, somewhere here. So yi is before the x. So yi less or equal to x, then ri become 0, and zi is between x plus 1 and x. So si will be between 0 and 1. So how to determine the si? So zi is actually x plus si. So zi is 52.78, x is 52 plus si. So we will get si is 0.78. So the ri and si for participant 2 in case 2 is 0 and 0.78. For participant 1, ri is in between the interval estimate, and for participant 2, zi is in between the interval estimate. This is how we calculate or we determine the ri and si. So recall yi, zi versus ri and si. So how to determine that one? How to differentiate between these two? Okay, this is the entry age. This is the exit age. For the whole study, for the whole observation period. However, ri and si also the entry and exit age, but this time only for the interval estimate x and x plus 1, x to x plus 1. Why we have round bracket and square bracket? Round bracket meaning that x is not included, and the square bracket meaning that x plus 1 is included in the interval. So we want to determine the qx. We want to estimate the qx or the px. Why? Because this is in complete data. So we have to monitor, we have to estimate one interval to conclude, to get the big picture for the whole observation period since it is incomplete data. So we want to estimate the QX and the PX to get the SX.